Good morning. This is grade 11 electrical technology class, and the chapter we are working with is a programmable logic controller, which is shortened by PLC. Whenever I say PLC, remember that this is programmable logic controller. And our subtopic under this PLC is a gate. At the end of this chapter or subsection, I'm expecting learners to have the following things. 1. Able to define each and every gate studied. And the second part is to draw the symbol and truth table in each. Also, the third one, I am expecting my learners to know the operation of each gate. The last one, which is the fourth one, to use the Boolean expression. This Boolean expression is a formula to determine the output using a common formula for such gate. And I hope everybody will be taking notes while I'll be teaching. Starting with function of the gate in 3 ways. Now in gate, mechanical, gate is used to open and close. So the word mechanical, it means that non-supply of electricity, no flow of current. It's working physically by itself. Nothing has been supplied to operate with electricity. So that's why we are saying this function of gate in 3 ways. The first one is mechanically. The gate is used to open and close. Secondly, we've got an electrical gate. By electrical gate, we mean a switch. A switch here is working as a gate, and it allows current to flow, or we stop the current to flow. So it's working as a gate. So electrical gate is form of switch, and it's used to switch on and off. The third is digitally. Digitally, we mean the switch, a gate, is written 1 to represent on and 0 to represent off. So that is digitally. Nowadays, all the electrical appliances are not written on and off. They use a digital method wherein on is 1 and off is 0. So that is what we will see or appear in our switch. Now, there are 6 types of gates, which of course I will name them. The first one is AND gate. The second one is OR gate. The third one is NOT gate. The fourth one is NAND gate. The fifth one is NOR gate. And the sixth one is exclusive OR gate. In our syllabus, which is grade 11 electrical technology, we are allowed to do only these 6 types of gates. Fundamentally, their function is the same. But where we are going to connect or let them work, they are different in terms of their operation. Then out of these 6, I'm going to start with the first one, which is called AND gate. So under this AND gate, I will indicate definition, what, where, and how. What I mean, the definition. Where I mean, where this AND gate is being used. And how I mean the operation. So out of these all 6 gates, I'm going to explain what, where, and how to each and every gate. The first gate is AND gate. Now the definition, which is what? It says is the electronic circuit that gives an output of 1 when both inputs are 1. That is the definition of AND gate, of which I can repeat it so that we will understand it more better when I'm going further. It says is the electronic circuit that gives an output of 1 when both inputs are 1. And in this explanation, in this definition, we have got new words of which I need to explain them so that you can understand it more better. Two new words are input and output. Remember, we should explain it clearly. I said, I said input, which means there are more than one. And I said output, which is always one. Now, input are switches. In this case, we were going to work with gate. When I talk of input, all of us, we must remember that I am talking about a switch. So inputs are switch, whereas output is our lamp. Output is our lamp. I'm saying this because almost when we talk of inputs, remember the switch. Almost when we talk of an output, you must remember that we are dealing with lamp. Now, 5 of these gates are going to use 2 inputs, meaning 2 inputs will mean 2 switches, except only one gate, which is called NOT gate, wherein we are going to have 1 input. By itself, naturally, it has been manufactured with 1 input. All other 5 gates are working with basic 2 inputs. It is not the must that all these inputs must have 2 inputs. No, those are the lowest number of inputs. There may be more than 2, there may be 3, there may be 4, there may be 5. For having 2 is a way so that these learners understand. A circuit diagram of AND gate is when 2 switches are connected in series with each other, and output lamp with source, which is a cell or a battery. Now these 2 switches, remember we said switches are inputs, are connected in series with each other, and output lamp with a source, which is a cell or a battery. They form what we call a circuit. Now this circuit, the way in which it has been connected, more especially when we talk of an input or switches, it will determine the type of gate. Now, under this first type of gate, which is AND gate, the operation of AND gate is as follows. Now, I'm answering the word or that which I said we're going to answer what, where, and how. Now, this operation is to answer how this AND gate is operated. When input A is 0, which is off, and input B is 0, which is off, the output X, which is lamp, will be off, which is 0. So I would like all of us to understand that when I say input A, I mean the first switch A is 0, means that that switch is off. If I say 0, I mean off. If I say 1, I mean on. That is a digital language. Now, the first operation, as I've said, it says when input A is 0, which is off, and input B is 0, which is off, the output X, which is lamp, will be off. In other words, the output lamp will not give us light. The second operation, it says when input A is 0, which is off, and input B is 1, which is on, the output X will be 0, which is off. In other words, the output X, which is our lamp, will not give us light because one of the 2 inputs, which are switches, is off. The third operation, it says when input A is 1, which is on, and input B is 0, which is off, the output X will be 0, which is off. This is our third operation of these 2 inputs and output. The fourth one, it says when input A is 1, which is on, and input B is 1, which is on. Now you can see that both inputs A and B are 1. Our output X, which is our lamp, will be 1. Meaning that when both inputs are 1, the output will be 1. Which goes back to the definition of AND gate, wherein we said it's an electronic circuit that gives an output of 1 when both inputs are 1. And our lamp will give us light when both switches are 1. Now, conclusion to this operation is that when both inputs, which are switches, are 1, then our output X, which is lamp, will be 1. That is the conclusion of AND gate under operation. Then, as we are working with reality, gate, an example of it is as follows. When one want to boil water, switch on the wall is off and the switch on the kettle is off. Water will not boil. We are talking of inputs and outputs. So here, our output will be water which is being boiled. Input are our two switches, wherein we are finding input A, which is the switch on the wall, input B, which is the switch on the kettle. So this operation which I'm giving and this reality which I'm giving, it says when switch on the wall is off and when switch on the kettle is off, then no water will be boiled. The combination of these switches are called AND gate because they should all work together. These two switches, if you want to boil water, they must together be on. If one of the two is 0, which is off, and the other one is 1, which is on, no boiling of water. Now, the formula to determine the output, which is X, or a lamp, is called Boolean expression. This is the way to determine our output using a formula. And the formula, in this case, is equals to X is equals to A and B. And here, in our language of electrical technology, it's a dot, which in mathematical situation is a multiplication. In other words, we are saying X is equals to A times B. That times, in our case, the correct language in electrical technology is N. So that's why I'm saying X is equals to A and B. X is representing the lamp, A is representing the switch, first switch, and B representing the second switch. Now, the second gate that we are going to deal with is OR gate. It's our second one. As I have already said, we are using the two inputs in 5 gates. So the second gate in this case is OR gate. OR gate is the electronic circuit that gives an output of 1 when both inputs are 1 or unequal. So for this definition, I'm answering what is OR gate. I'm answering what. Remember we said we have got what, where, and how. For this case, I've answered what is a gate. Now, the circuit inputs are connected in parallel and named A and B, meaning that both are switches and output is lamp and marked X. This gate is commonly used in a long passage and flat where one switches on when he or she enters and switches off when leaving the stairs to the first floor. The symbol is drawn using American symbol and British symbol. You are not allowed to mix these symbols. If you're using American, complete with American. If you are using with the British, complete it with British symbol. Thank you.